6.4, rational equations. So a rational equation is an equation that contains at least one rational expression. You can use a rational equation to solve problems where the unknown value is in the denominator. So for example, if we have x plus 4 over x equals 4, that's a rational equation. To solve, first of all, we factor denominators if necessary and determine the least common. So sometimes it'll already be given factors, but if not, our first step is to factor the denominators. Then we do our non-permissibles. We multiply all terms on both sides by the lowest common denominator. We solve for the variable. We have to check that they are permissible and that they make sense. Okay, if we're talking about length and we get a negative number, that does not make sense. And then we verify that any remaining solutions are correct in the original equation. And they go through a pretty good example here in these key ideas. So x plus 4 over x equals 4. So step 1, factor the denominators, already done. The only denominator is right here, and that's factored. Identify non-permissible values. So right here they would say x cannot equal 0 because that denominator cannot be 0. Determine the least common denominator. So the least common denominator, since there's only one, is x. Then we multiply all terms on both sides by x. And that's what they did here. They multiplied this side by x and that side by x. So using the distributed property, they found that this was x times x plus x times 4 over x equals 4x. They got x squared plus 4 equals 4x. Okay. What happens next here is they collected all terms on the same side and they saw that they had a quadratic. They had x minus 2 and x minus 2. That's a perfect square. So they set them to 0, so they said that x must equal 2. Is this permitted? That was the next step. X could not equal 0, so yes, that is permitted. But the final thing they have to do is they have to sub it into their original equation. Well, does 2 plus 4 over 2 equal 4? Because remember this was the original equation, and they showed that the left side equals the right side, so that is a solution. Okay, let's look over here. It says solve this equation and verify the solution. So step 1 was to factor the denominators. Almost all factored, but let's check this out. X squared plus 25 plus x plus 5. This one's over 2. That one's over x minus 7. 2x squared minus 12x minus 9. This denominator was not factored, so we would factor out a 2x minus 7. Okay? Lowest common denominator is what we have to do now. So we have 3 denominators. So it's like I could do 3 circles. Okay? In the first denominator, we have x minus 7. Now that is found in both the first one and the third one. So that's found here, first and third, x minus 7. Okay? The next one is 2. That is found in both the second one. That's found both here and here. And you'll notice, sorry, in the second one and the third one, and this is already taken. So our lowest common denominator is going to be 2 times x minus 7. Okay? Now we have to do non-permissibles. The only non-permissible is x minus 7 cannot be 0, so x cannot be 7. So now we need to multiply every term by what's missing. Okay? Or no, sorry, we need to multiply every term. I need to go back to my steps. All terms on both sides of the equation by the lowest common denominator. So every single term here has to be multiplied by 2 times x minus 7. Okay? So we're going to multiply this term by 2 times x minus 7. We're going to multiply this term by 2 times x minus 7. And we're going to multiply this term by 2 times x minus 7. Okay, when we multiply here, the x minus 7's cancel out, and we get 2 times x squared plus 25. So multiplying by this lowest common denominator gets rid of my fractions. Here the 2's cancel out, and I get plus x plus 5, x minus 7. Okay, on this side, both the 2's and the x minus 7's cancel out, and I'm left with 2x squared minus 12x minus 9. So now I need to do some simplifying and collecting like terms. So this might take me a couple steps. So here I have 2x squared, oops, 2x squared plus 50. And now I need to FOIL these two terms. I get x squared minus 7x plus 5x minus 35 is equal to 2x squared minus 12x minus 9. Okay. Still collecting like terms. First of all, I notice that 2x squared's on both sides, so I know those two are going to cancel. So I'll do that first. And it looks like my x squared's on this side, so I'm going to bring everything to this side. So x squared, I only have one x squared. Okay, I've taken care of that one. Now let's look at my x's. I have minus 7 plus 5, so I have negative 2x, and then I have, when I bring it to this side, I'll have 12. So negative 2 plus 12 will be 8x. Okay, so I've taken care of those. Now I have 50 minus 35, so that's 15, and then I'm going to add 9 to it. 15 plus 9 is 24. 15 plus 9 is 24. Okay, let's hope I did my adding right there. So now I need to solve a quadratic, and you guys know that we have a bunch of ways we can solve a quadratic. Quadratic equation, factoring, graphing. What's the last one? There's one more way. Completing the square. There we go. Okay, so first of all, I'm going to look to factor. Are there two numbers that multiply to be 24 and add to be 8? Multiply to be 24, positive 24, add to be 8. Okay, no wonder I have a problem here. I made a mistake on this term. Negative 2x plus 12 is 10x. That's why. So two numbers that multiply to be 24 and add to be 10. Well, that's going to be 6 and 4. So I'm going to get x plus 6. X plus 4. Okay, setting each factor, I get x is equal to negative 6, and I get x is equal to negative 4. Okay, now I have to check. Does that, do these two things satisfy those non-permissible values? So I said my non-permissible value is that x cannot equal 7, so that's okay. So they seem to be okay, but I need to substitute into my original equation. Okay, so remember that my original equation was x squared plus 25 over x minus 7 plus x plus 5 over 2 is equal to 2x squared minus 12x minus 9 over 2x minus 14. So let's try negative 4. Let's see if we sub in negative 4. Or no, negative 6. Do negative 6. So we have negative 6 squared plus 25 over negative 4. Oops. Try 7 in the same thing, Miss Gallon. Negative 6 minus 7 plus negative 6 plus 5 over 2. Does that equal 2 times negative 6 squared minus 12 times negative 6 minus 9 over 2 times negative 6 minus 14? Okay, so what I'm going to do is I'm going to simplify the left side and simplify the right side and show that they're the same. So this is 36 plus 25 over negative 13 plus 1/2, negative 1/2. Is that equal to 2 times 36 plus 6 times 12 is 72 minus 9 over negative 12 minus 14. This is a lot of fraction work here. 36 plus 25 would be 61 over negative 13 minus 1/2. Is that equal to 2 times 36 would be 72 plus 72 minus 9 over negative 12 minus 14 would be negative 28. Oh gosh. 61 over 13. Is 61 divisible by 13? No, of course it's not. So we need a common denominator here between 13 and 2. I'm just going to pause and do some math here. Okay, so doing some simplifying, I showed that these two were not equal. So that means x equals -6 is not a solution. But let's try that first solution we did. X equals -4. Let's try that one. See if that one is a real solution. -4. Let's sub it in here. Okay, so we have -4 squared plus 25 is equal to -4 minus 7 plus -4 plus 5 over 2. Does that equal to 2 times -4 squared minus 12 times -4 minus 9 over 2 times -4 minus 14. Okay, so we have 16 plus 25 over here, minus 11, plus, minus, positive 1/2, rather. Is that equal to 2 times 16 plus 4 times 12, 48, minus 9 over -8 minus 14. Okay, 16 plus 25. 41. -41/11 plus half. Is that equal to 2 times 16 plus 48 minus 9? 71 over -8 minus 14. 22. Oh, this is looking kind of good. Okay. Negative here, right? Because that's a negative. Okay. So we're going to make this into 20 seconds as well. So 41 times 2, we have -82, and this is going to be plus 11 over 22, because what I did in that step is I times this side by 2 over 2, and I times this side by 11 over 11, right? Those are just forms of 1. That gives us a common denominator. Is this equal to -71 over 22? You better believe it does. This is -71 over 22. Since the left side equals the right side, then yes, x equals -4 is a solution. Okay, I know that was a ton of work, but that's what these problems are, and you can always know for sure that you have the right answer.